So here we have the graph of g of x. Any guesses what kind of graph g of x is? It is an x cubed graph of some sort. So if you think about your parent graph, the x cubed one, the shape that it has, this one's just a little bit more wonky. We need to graph y equals g of negative x. What's another way that could have been written? Y or x? The last one was y, so the textbook wouldn't do that twice in a row, right?
No, but I mean, because the last one's inside.
Yeah, this one's outside, so our y values are getting multiplied by negative. We can imagine that's going to flip it over the x-axis. If it was written as an equation over the line, what's the equation of the x-axis? Y equals 0. So again, it's good to talk about the different ways that this question could be asked. If I'm looking at specific points, I probably choose this point and this point. This looks like it's at 1, 5 is what I wanted you to say. I wanted you to say 5 so that you'd realize your mistake. Because every once in a while, graphs from quizzes and tests come up like this, and people label that point as 1, 5. And it's 1, 6 because he's going by 2s. Oh, trickery. And this one is at 3, oh, you want to say 1, don't you? 3, 2. And you know what's worse than falling for the trickery the first time? It's falling for the trickery the second time after you fell for it the first time. And now if we flip it over the x-axis, we'll change our color here. Down here now we have 1, -6, 3, -2. These two graphs are going to intersect at one and only one point. And if you are asked on a final exam or a quiz or a test to draw these graphs on the same graph, they're going to look if you accurately have them intersect at the one and only one point where they do intersect. How are you going to figure that out? Because there I'm going to have this go like that and down, and then it's going to come up. How did I do? Am I accurate? Did it intersect at the one and exactly one point where it should have?
Yeah. No.
Not quite. I was a little lazy. I just drew it quickly. So this is not the right spot where it's supposed to intersect. So I'm going to erase that section.
Yeah, it's also.
Where is it going to intersect? On the 0. There it is. Why does it intersect at the x-intercept at the 0? That's where the line that is crossing it, right? Then they're just flipped over that. And if you think about that point, if we try to imagine, we're going to make up that point on our original graph. It looks like it's at negative 0.138. Yeah, I think so. Comma, what? 0. Really, the x doesn't matter. Now, when we flip it over the x-axis, what value is changing? What are we doing? We're multiplying our y-coordinate by a negative. So when we do that, the x will not change, so we'll still have a negative 138. And now our 0 becomes negative, which doesn't do anything. It stays 0. You wouldn't actually write a negative 0 there. It's just 0. So that's the point that's going to stay the same. All right. We need to state the domain and range of each of our functions. So our red graph, first domain and range, and then we'll do our green one after that. The domain for this one, we're going to imagine these had arrowheads going on forever. It's a cubic function. The domain is everything. And since the arrowheads go up and down forever, the range is everything. Now on our green graph's domain and range, well, first of all, by flipping it over the x-axis, you're changing the y values. So we already know that our x values will still have the same domain. But even if we multiplied our y values by a negative, and it was everything to begin with, you're still going to have everything again. Four, 5, 6, 10, and 11.